All right, so we have here, it says use radical notation to write the expression. Simplify if possible. Assume that all variables represent positive numbers. Okay? So, our first example, we have here 4 to the 3/2 power. 4 to the 3/2 power. How would we write 4 to the 3/2 as a radical? The square root of 4, and then we can say cube. Now, or it could have been written as the square root of 4 cubed. I want you to understand we're still going to get the same answer no matter which way we put that exponent. If we want to put the exponent to that base, which will be the radicand, or if you want to put it on the outside, we're going to end up with the same answer. Because let's look at the first one, the square root of 4, which is 2. And then 2 cubed gives us 8. Well, the second way, if you write it this way, you're saying the square root of 4 cubed. Well, we take 4 cubed, which is, so that's 64, and then we take the square root of 64. We have 8. I need you to see it both ways because I want you to understand that it doesn't matter because we're going to end up with the same answer. B. We have here negative 256 to the 3/4 power. Now this is similar to what we had on the board. What is being raised to the 3/4 power? The negative, the 256, or both? The 256. So you're saying negative times 256 raised to the 3/4. We're going to make that 3/4 into, let's do it that way, make the 3/4 into a radical. So what you're saying here is negative times, what's the index? What will be the index here? 4. You're saying the 4th root of 256 cubed. And see, what I was telling you before, why I like to write it this way. Imagine if we wrote the other way with the cube to the 256. That means we need to find 3 factors of 256, multiply. You know how large that number is? And then we take the 4th root of it. Now that right there, you need a calculator for. But the 4th root of 256, you can find that. 4 times 4 times 4 times 4 times 4. Okay? So you're saying here, negative times 4 cubed, which gives us negative times 64, and our solution is negative 64. Go ahead.
Where did you get 64? Okay,
4 cubed.
Okay.
Yes. 4 times 4 is 16, and then 16 times 4 is 64.
If you didn't use parentheses?
How would I have used it differently? I would have wrote it as the 4th root of 256, and then all of that is cubed.
So then how would you get that answer?
Because we need a calculator for that. 256 times 256 times 256. So you imagine how large that number is, and then take the 4th root of it, and that's what it's going to give us, 64.
Oh, okay. Where did you So you don't do anything with
Right here?
Yeah.
Yeah. We took the 4th root of 256, which gives us 4.
Oh.
And then we cubed it. We cubed whatever this solution was here.
So 4 times 4 is 256. 4. You times 4 times.
Let me pause. C, we have the quantity of 1/4 raised to the 3/2. You're saying the square root of 1/4, and then all of that is being cubed. That's what you're saying. Now, order of operations still comes into place here because you have to do what's inside the parentheses first and then use the exponents. Please excuse. P, parentheses, that means any grouping symbol. E, exponent. So, the square root of 1/4. What's the square root of 1? What's the square root of 4? So, then you're saying 1/2, and then we're going to cube it. You're working inside first, the parenthesis, and then we're going to raise it to that power. 1/2. 1/2 times 1/2 times 1/2. How do you multiply fractions? Straight across. Or we can use our exponent rule that says that we can take this outer exponent of 3 and distribute this as an exponent to the numerator and to the denominator. And we have 1/8. D. We have here the quantity of 3x to the 2/3 power. Now, it does say read your directions. It says use radical notation to write the expression. Simplify if possible. So some of these can be simplified and some of these cannot. I can tell you the ones where the base happens to be or is a number, you will be simplifying. Okay? Let's look at this. How will we convert the quantity of 3x raised to the 2/3 power? How will we convert that to a radical? What is the index? What is the exponent?
Cube root of 3x, right?
Okay, yes. Your index is 3, so you're saying the cube root of. When parentheses are enclosed, that means all of that goes to, that's in that radical. You're saying 3x, and then we're squaring it. Now, there's no such thing as trying to find the cube root of 3. We can't find the cube root of 3. Okay? You can't find 3 identical factors that would give you 3. If you can, please tell me. Show me how you do that. Okay? So, cube root of 3, we can't find the cube root of. The cube root of x, we can't find the cube root of that. There's nothing that we can do. You have that possibility. Simplify if possible. You've done everything that you could for this one. You've changed this rational exponent to a radical. That's it. E, let's do another one. We have here the quantity of 4x minus 1 all raised to the 3/5 power. Okay? How would we write this out as a radical? What's the root? The index. So, the 5th root of what goes inside? All raised to the what? There you go. 4x minus 1 we can't do anything to that. It's not factorable. We keep it as is. That's it. All right, last one of this one. 27 to the negative 2/3. Now we have something where the exponent is negative. Now we need to go back because all of this stuff that we've done before is not going anywhere. It's still going to come back. We have a property that's called the negative exponent property. The negative exponent property says that, hey, we can't have any exponents that are negative, so we have to make those exponents positive by doing what? What's that R word? Huh? Right, taking the reciprocal. Okay? The base still doesn't change. The exponent becomes positive. So when we're talking about reciprocal, we're talking about fraction. It may or may not end up being a fraction. If it starts off as a fraction and had this expression been in the denominator, it would have moved up to the numerator. But it's not written as a fraction, but we can always make it into a fraction by placing a 1 under it. And then you're saying here, now make the exponent positive. I'm going to circle this. That's going to go, what's in the numerator, take its reciprocal, is going to go to the denominator. The base stays the same. So you're saying 1 all over 27 to the 2/3 power. Try to take some of that glare out. Okay? All right. So, let's convert this denominator into let's convert it as a radical so we can see how to simplify it. Okay? So, you're saying the cube root of 27 squared. First of all, let's work inside the parenthesis. What is the cube root of 27? 3. We're looking for 3 identical factors. So 3 times 3 times 3 is 27. So its root is 3. So then you're saying 3, and then we have squared, and 3 squared gives us 9. That is our answer.